Hello again. This might be a little ambitious, but I want to talk about a parent function, a parent linear function. The parent linear function that you're going to see in algebra, but whether or not it's referred to as by other people, is y equals x. Basically, it's the basic linear function that you deal with. I also have some other examples that I want you to do. Y equals x plus 2, y equals x minus 2, y equals negative x, y equals 2x, y equals negative 2x, y equals 1/2 x, y equals negative 1/2 x. I want you to be able to graph all the functions. I want you to be able to tell me if they have a y-intercept. I want you to be able to tell me if they are positive or negative in terms of slope. It's as simple as that. Power of video, you get to see all of this anyways. I'm going to go ahead and say this right now. The domain and range for all of them are negative infinity to infinity and negative infinity to infinity. So there's no big surprise there. We're going to start with our first function, which for some bizarre reason students get wrong very often. Initially when they do this. They can do this one, this one, this one, but they feel uncomfortable about this one. Let me say this right now. In order to graph, the first thing you have to do is graph the y-intercept. A few of these are special. This one, y equals negative x, y equals negative 1/2 x, y equals 1/2 x, y equals negative 2x, and y equals 2x are all special in the fact that the intercept is not given. The y-intercept. Actually it is. The y-intercept, if it's not stated, is 0. You don't plot anything except the y-intercept at 0. So, with that said, we are going to graph this one first. Y equals x. Now, if it will help you, and you need to get a y-intercept first, put in plus 0, because that's essentially what the y-intercept is. So the y-intercept for that one is 0. The slope is, if not given, 1 over 1. So it's rise 1 over 1 from the y-intercept. Up 1 over 1. Connect the dots. Make it continuous. Congratulations, you just graphed y equals x. How does this graph and this graph differ from the parent function? Well, it's very simple. They have a y-intercept of 2 and negative 2. How does that change the graph? Glad you asked. Let's graph this one. Plot the y-intercept first. It's at 2. And always from the y-intercept, you plot the slope, which is 1 over 1. While we're at it, let's do this one. The slope is 1 over 1, but we're not going to do that until we take care of the y-intercept, which is negative 2. And from the y-intercept, you plug in the slope, 1 over 1. These three graphs are special in the fact that, if they were drawn properly, would never intersect. They're parallel lines. They all have the same slope, and they have different y-intercepts. X, x, x. All the same slopes. Negative x is not the same slope. It's negative. All of these are positive 1 over 1. This one is negative 1 over 1, so it's not the same. Now, they're parallel because the slopes are the same, but their starting points, 2, 0, and negative 2, are different. It means that they will never touch if you have the same slope. It's like building a house. You never want two opposite walls to touch each other, because what happens is it's going to cave in. So they're built on parallel slopes. Very interesting in its own right. Check it out. Your own room, your school desk should be a parallel slope, all that good stuff. Okay, let's graph this one. Y equals negative x. The y-intercept is 0, but the slope is negative 1 over 1. So that graph cuts through them like butter. We got ourselves some pretty fascinating drawings here. Y equals 2x. Again, the y-intercept is at 0, but this one is different. Y equals x is this graph right here. What do you think a bigger number will do to a line? And it does change it. Let's find out. The slope is 2 over 1. What happens is, it rises faster than a parent function. As you can see, this is probably very cluttered, but fortunately, since it's done on video, you can carefully analyze it. Y equals negative 2x is the same thing as y equals negative 2x over 1. Y-intercept is at 0. So you plot it, and then you take care of the slope, which is negative 2 over 1. If that were drawn better, you could see that it's more pronounced, but what it's supposed to do is go down a lot faster, which it kind of does, but since my graph isn't perfect, and that's my own fault, whatever. People have been doing it for hundreds of years without smart boards, so I'm not going to take that much blame for it. Next one is y equals 1/2 x. The y-intercept for both of these last two is at 0. But this time you go up 1 over 2 and down 1 over 2. So we'll see how each one looks. And y equals negative 1/2 x. You can see what happens is that the slope rises slower. Y equals 1/2, y equals x, y equals 2x. So that's what happens. When you put a number in front of the x, depending if it's bigger or smaller, a smaller number will rise slower, bigger number will rise faster. If you put a number after the x, if it's positive, the graph will start higher. If it's negative, it will start lower. If the slope is negative, it will go downwards. And if the slope is positive, it will go upwards. Looks like a spider web. Maybe that makes me Peter Parker. Yeah, that's not true. Well, I hope that wasn't too confusing. Have a great day for now. Goodbye.